Okay, so today we're going to be talking about proving segment relationships. So, this is going to be very similar to our algebraic and geometric proofs. There's still going to be two column proofs, but we're just going to have a couple new postulates and properties today. So, our first postulate is the ruler postulate, which essentially says if any segment lies on a ruler or anything with set distance, and one of them lies on 0, such as point A does here, then the other point, so point B, corresponds to a positive real number, and that positive real number is going to be the measurement. So, if you need to take a second to write that down, you can write that down or know that it's in the slides in 2.7 on Schoology. So the second one is the segment addition postulate. So what this says, if A, B, and C are collinear, and point B is between point A and C, if and only if AB plus BC equals AC. So this is something that we've covered before. If you feel like you need to write it down, go ahead and write it down. Just like the ruler postulate, if you feel like you should put it in your notes, put it in your notes. If you feel like it's not necessary, go ahead and skip it. So let's see here. So the next things are our new properties. So we have reflexive, symmetric, and transitive properties of congruence. So these are just like the reflexive, symmetric, and transitive properties of equality that we covered last time, except for now they relate to congruence. So instead of saying equals, they'll say is congruent. You can still abbreviate these. I wouldn't write out the whole thing. It seems a bit excessive. So reflexive property of congruence is just saying one line is congruent to itself. The symmetric property of congruence would be when you flip it. So AB is congruent to CD, then CD is also congruent to AB. So if you flip it back and forth, they're the same thing. And then the transitive is when we have multiple segments that we're comparing. So if AB is the same as CD and CD is the same as EF, then by definition, AB and EF would be the same as well, since they're all congruent to each other. So if you want to take a minute and write these in your notes, go ahead and pause the video. We're going to go back and look at some examples and kind of how these will look. So this is the first example that's given. They want us to prove that AB is congruent to CD. They want us to prove that AC is congruent to BD, given that AB is congruent to CD. So our first step would be to write our given down here, which they do for us. They've done this whole proof for us. So the second step, they change all these to equals. I don't feel that's necessary. So I would shorten this proof and I wouldn't write as many steps as they do. But if you want to write out all of them, you can write out all of them. So the first thing they do is they say, well, instead of AB being congruent to CD, we're going to say AB equals CD. And we're going to use the definition of congruent segments. Once again, I don't feel that step's completely necessary, so I would skip that. Same thing with BC is equal to BC by the reflexive property of equality. I feel like that's part of the given. BC is, of course, going to equal BC because BC is BC. I feel like it's a bit ridiculous to have to state that. Then they also give us the AB plus BC equals AC, and then the next step they're going to give us CD plus BC equals AC. Or no, I'm sorry, they switch those up. So this step 4, they give us the segment addition postulate. I don't particularly care for that either. So if I was going to solve this proof, what I would do, I would write the given just like they did. Then I would say, okay, so if AB is congruent to CD, then that's given. Then I would say AC, or A plus B, AB plus BC equals. So let's do this instead. Let's highlight the steps that I would put in here for you guys. So I'm going to highlight the steps that I think are necessary. So this given step is necessary. Then I would write the segment addition postulate saying that this piece that I highlighted is the same as this piece. That's what the segment addition postulate is saying here. They use the segment addition postulate in conjunction with this substitution property of equality. And then they double state, so they go back and they state this segment addition postulate again. I wouldn't do that. I would skip that. And then I would go straight into them being congruent by definition of congruent segments. So this one's kind of a mess. How they did it, I would skip a lot of the steps and cut this from an 8-step proof to a 4-step proof. Which if you're solving it on your own, you can totally do that. So the second one that I'm particularly more interested in is this one, where we're writing ourselves a 2-column proof. So we have reason, or I'm sorry, I messed that up. Statement, reason, which my spelling is not great today. So they give us these 3 statements here. So I'm going to write them all out separately. You could write these all together too. AC equals AB, AB equals BX, and CY equals XD. And I'm going to write given, given, and given, since all that stuff's given. Now, what I like to do on my picture here is I like to mark these off. So AC is the same as AB, AB is the same as BX, and then CY is the same as XD. So, sorry, I should do 2 dashes there to show that those two are the same. Okay, and I am trying to prove AY is the same as BD. So, based on the information I have, I'm going to say, based on, where did it go? So based on the transitive property of congruence, I can say that AC is congruent to BX by trans property. Then based on that, I can also say, or no, so based on the addition, I can say AC plus CY equals AY based on segment addition. And then I can also say that BX plus XD equals BD by the same thing, segment addition. Then the last thing I would say, is based on, let's see here. So then I could say by substitution that AY equals BD by substitution property. So essentially what I've done, I have taken this chunk that's given as my first step. Then my second step is showing that AC is the same as BX. Now, that wasn't explicitly given, that's why I wrote that out. My third step and my fourth step are just saying, okay, if I add these segments together, I get this whole segment. And I'm saying that for both of these. And then my last step is essentially saying I can substitute out AC for BX because they're equal. And I can substitute CY and XD because they are equal, which means that both of these AY and BD also have to be equal. So that's an example of a segment proof. This one is very similar. So in this they say GD is the same as BC, which the picture doesn't show that, but whatever. Then BC is the same as FH, and then FH is the same as AE. And they want us to prove that AE is the same as GD. So with all of this being given, what I can say is, based solely on this transitive property of congruence, I can say that GD is congruent to AE. Because I can say, well, since AE is the same as FH, and FH is the same as BC, and BC is the same as GD, then they are congruent based on the transitive property of congruence. So, my proof, if I were to write this out, I would have my statements, my reasons. So, I would just write these three as my first one as my given. Then my second one, I would just go ahead and rewrite saying, since FH is I would pretty much write the same thing again. I would say since FH is congruent to AE, which is congruent to BC, which is congruent to GD. And I would say transitive property of congruence. So that's how I would end up writing that proof. Now, when they do it, they give way more steps. I just don't think it's necessary to give that many steps. So please feel free to shorten these as much as you would like. Less steps, the better.